Welcome back to the third part of the lesson today. So we've constructed the dual, we've constructed the canonical form of the original, and now from this canonical form, we're going to construct a phase one. Okay, remember the dual, this is here. This is all about finding the greatest lower bound of a min. If this had been a max, it would have been the least upper bound. Canonical form is what simplex needs. And now phase one is to find an initial basic feasible solution. Okay, so they all are referencing really the original LP, but in different ways. Phase one, we actually use the canonical form. So phase one is an advancement of the canonical form, and it's what we can do before we can actually go back to the canonical form and solve it. So I see three constraints. I know I need three artificial variables, A1 plus A2 plus A3, and they're artificial, so I'm going to need to try to get rid of them. If I can, then it will mean the canonical form, the original LP, are feasible if this objective is 0 at optimality. The problem I'm going to run into, makes this a little different than perhaps others you may have seen, is this second constraint, which will be associated with A2. The reason why is that right-hand side is negative, okay? The first constraint is not so bad. It's x1 plus minus x1 minus plus x2 plus x3 minus x4. And it's plus A1 equaling to 19. And that's fine because A1 equal to 19 is going to be part of my initial basic feasible solution for phase one. Note that that is not possible in the canonical form, right? This is the whole point. We're adding an artificial variable to create a feasible point. That's also a basic solution. The second constraint, I need to flip the signs on both sides. I need to multiply both sides by -1. So I'll just do that as I write it. It's going to be 4x2 plus 8x4 minus s1 plus a2 equals 55. Note how s1 equal to -55 is infeasible. Similarly, so if I just added a2 and set it equal to -55, that's infeasible. It violates non-negativity. So that's why I have to multiply both sides by -1. And that's equivalent. That's fair to do. It's an equality constraint. I can do that, and it's still the same constraint. Okay, and the final one is similar to the first constraint. The third, I just write it down. x1 plus minus x1 minus plus 6x2 minus x3 minus s2 plus a3 equals 7. And of course, all variables in canonical form, this is still canonical form. It's just the phase one of that problem. x4, s1, s2, a1,